Welcome back to geometry. We're going to take a look at section 17. And we've already taken a look at some basic definitions and some theorems. And what I'd like to do is I'd like to move on to a couple of theorems that we actually will prove. So theorem 17.10, the isosceles trapezoid properties. In an isosceles trapezoid, the base angles are congruent and the diagonals are congruent. All right, so let's consider an isosceles trapezoid. So in a trapezoid, there is exactly one pair of parallel sides. So that's what we have here. The top and the base, right? The top and the base are both parallel to one another. So let's see if we can get something that looks approximately like a trapezoid, or like an isosceles trapezoid rather. So that looks pretty good. Right, isosceles trapezoid. Let's go ahead and label these vertices as A, B, C, and D. And what we're saying here is that the base angles, angle A and angle D, are congruent. And we're looking at the diagonals are congruent. Excellent. So I'm going to get rid of these because we'll have to add some additional notations here shortly. But what makes it an isosceles trapezoid is that we have that the sides are congruent. All right. So let's prove part A. So we want to assume that we have an isosceles trapezoid, and we want to show that the base angles are congruent. All right, so first, of course, A, B, C, D is a trapezoid. And we have that AB is equal to CD. So it's a trapezoid, and this makes it isosceles. So this is given. Because it's a trapezoid, of course, we have that the base is parallel to the top. Right? That's just the definition of trapezoid. All right. So what we want to do in order to show that these are congruent, we're going to have to use quite preferably something about parallelograms, right? Because we have quite a bit about parallelograms, or something with triangles. So I want to get a relationship between this and this somehow. All right. At this time, again, I don't know much about it. I want to show that these two angles are the same. So what I'm going to do is I'm going to first create a parallelogram. And I'm going to do that by finding a line that's parallel to AB. So let's let CX be parallel to AB. So what we're saying is we've got some line here that is parallel to AB, and we're calling this point X. All right, and this we can say that this happens because given a line and a point, we can find a C in this case. Given a line and a point, we can find a parallel through the point. So this is given by the parallel existence theorem. Excellent. All right. Once we have that, we have 1, 2 pairs of parallel sides. So by the definition of parallelogram, we have that A, B, C, X is a parallelogram. Again, that's by the definition of parallelogram. So what does that get us? Excuse me. We have then that AB is congruent to XC, or that the distance from A to B is equal to the distance from X to C. And right, we got that from our theorem 17.4, I believe it was, on the top of the next page, 17.3, right? Both pairs of opposite sides are congruent. That's what we have here. So this is by theorem 17.3. In particular, we're using B there. All right. So that is going to give us an isosceles triangle, in which case this angle measure and that angle measure match. And we just have to figure out then, well, hey, does this guy match that? That's essentially what we're working towards now at this point. All right, so we have that since AB is equal to XC and AB is equal to CD, we can formally say that CD is equal to XC, which is what we just said. And this is by the transitive property of equality. So because AB is equal to CD and CD is equal to XC, we have, since AB is equal to XC and AB is equal to CD, right, we can connect these two things, CD and XC. Excellent. So that gives us that the angle measure here, right, angle measure 1 is equal to the angle measure at D. So the two angles are congruent. And this is by the isosceles triangle theorem. All right. So how is this angle and that angle related? Right, we want to show that this angle and that angle are the same. And we have that, right? We have a pair of parallel lines. And by the converse of the corresponding angles theorem, when we have parallel lines, then the corresponding angles are congruent. So angle A is congruent to angle 1 by the converse of the corresponding angles corollary. All right, well, that gives us that A is congruent to 1 and 1 is congruent to D, and by the transitive property of congruence, we have that A is congruent to D, which is exactly what we wanted. The base angles are congruent. So we get exactly what we wanted. Angle A is congruent to angle D. And this is by the transitive property of congruence. Excellent. And again, that's exactly what we were hoping to show. So we're done. All right. because I'm hoping to have a bunch of short videos for this section, we'll go ahead and pause here again, and we'll take a look at the last theorem in our last video. I hope you guys are doing well today. I'll see you back here in just a minute.